This is where the batch production molds are made. And this is Butch Koop, who is going to make one for us today. Now, what happens first? Now, see, you have a big strip of some rubbery-looking substance.
This is pure rubber, which has not been vulcanized yet. It's chemically mixed to put it in a solid form until it's vulcanized. What I do is cut this into strips here and pack them together. They haven't been vulcanized, so they're pretty sticky right now.
Yeah.
Then after I pack them into rubber, what we'll do is put them in a frame, put them in a vulcanizer with heat and pressure for about 45 minutes, and it will turn into one solid block of rubber. And from there, we will cut the pattern out. This is a sprue former. This will form the round hole where the wax is injected into the mold.
Okay.
One of the tricks to this art is remembering exactly what's inside the mold so you know where to make your mold lines. You have to cut on a corner so you don't get mold lines or casting marks. This is the press over here. What I will do now is exert a little bit of pressure. Keep turning it down a little bit at a time for 5 minutes until I get it pretty tight.
I can hear it making bubbling noises.
Right. There's a little bit of water left on the plates from the last mold I did. Is mainly what the water was, you heard. Steaming sound.
And you set the timer?
45 minutes.
And you don't touch that wheel again?
I will touch it periodically for the next 5 minutes.
Okay.
As the heat is traveling through the rubber, I gradually put pressure on it.
Now that rubber is flowing all around,
right,
into every little nook and cranny of that metal model.
Exactly.
Now Ken, what happens to this mold when it arrives in here and a casting is to be made?
Okay, it's put into the oven in order to burn the wax out of it. The machine comes on approximately at midnight, and it works on this rotor here.
Yeah.
It comes on and it burns out until you use about 7 or 8 o'clock. It goes up to 1,400 degrees, and then it would fall back down to about 900.
Okay.
At which time I would come in and preset it to temperatures I would desire.
And those temperatures are affected by whatever gold it is that you're going to be casting. Is that right?
Yes, it is. Usually around 900-1,000 degrees would be for yellow gold, unless it be a very heavy ring. Then I'd go for an 800 degrees. Or if it was a white gold with a lot of little detail, it could take it up to 1,100-1,200 degrees.
Okay. When you've got this hot mold in here, you open that magic-looking lid, bring it out with a pair of tongs very carefully, I suppose, and you bring it over to this centrifugal casting machine here, which looks like a box of tricks if ever I saw one. So they take this, assuming that my hands are tongs, which they are not, you would drop it in here.
Correct.
Close up this clamp, and then proceed to spin the caster. Is that right?
Right.
How long would you spin it for?
Approximately about 30 seconds would be long enough for it. Just to get it so the gold is cool enough so it won't flow back out of the tube.
So do you have any control over the speed at which this spins?
Yes, there's over here's how I control the speed. It ranges from 350 to 800 RPMs. If it's a very big, heavy ring, again, you'd go slower. And if there's a lot of detail you want to bring up, you spin faster.
So this gold in here will be, in the case of a heavy ring, at a lower temperature than for a small ring, and furthermore, you will spin this slower and usually for a longer time, I take it.
Right, to keep the porosity out of it.
Okay. So you pick the mold, again with tongs, out of here and transported over here?
Right, it goes on to here, and so it cools down partially. Usually takes about 10 minutes for yellow gold and 12, 13 minutes for white gold.
Okay, what happens next?
Then it gets quenched in the water, where now the gold is fairly cool, but the tube is still hot, so the plaster can flake out.
And then what happens then? I'm sorry to have interrupted you. What does happen then?
Then you take the button that's left and you put it in here in the acid, so that the investment that is left on the ring will break down.
What kind of acid is it?
It's muriatic acid and a mixture of water. And
how long do you leave it in there?
Usually doesn't take too long. Usually a couple minutes would do it long enough, and then take with the hose and water and air pressure and blow off the excess investment off of it.
I see. The next thing that happens is that somewhere the sprue or the little throat through which the gold was poured into the models is cut off, and it then goes to the finishing benches that you have out there. Fine. Thank you very much, Ken.
Thank you.
Okay, Dick, what are you going to set there for us?
Well, I'm going to put a diamond in this ring here on the side.
How big is the diamond?
This one is approximately 9-pointer.
Oh, about 1/10 of a carat.
Say 10-pointer, yeah.
So what did you do before you dropped it in place there?
The ring is filled with shellac, so it won't bend. And we fill it up so it makes it sturdy. And I have to dig that all out before I can put the stone in.
Oh, I see. A sort of preventive activity.
Right.
Yeah.
All I'm doing now is pushing the prong over on it.
How long have you been setting diamonds, Dick?
Roughly off and on for about 40 years.
Oh, great Scott, I should think you know how to do it by now.
Push the prong off, over it, and then I take this and I cut the excess off.
That must be a nice pair of side cutters you've got there.
Yeah.
Very fine cut.
It is. Very sharp.
So now it'll have a slightly jagged edge or end to it, won't
Right.
it? Prong?
And then what I'll do is I have a, what we call a cup burr. It's an inverted burr, and I'll round that off. I don't know if you can pick that up, but now you can see that
Oh, you have
makes
to...
a very nice round bead on it.
Oh, yes.
And then I can continue on.
So that now, when a lady wears that ring, it won't catch in her clothing?
No.
Now you're going to continue on, set the remainder, and what stone will you be putting in the middle, Dick?
I'm going to put a marquee in the center, but that has yet to have the center stone, or center setting put in there.
I see. My word, that'll be a beautiful ring when you're through. Well, that's the end of our little tour. We have seen that considerable expertise goes into the making of high-quality jewelry. It isn't just a matter of throwing materials into a machine and finished items clink merrily out. It is almost an axiom that you get only what you pay for. There is a lot of low-grade merchandise out there. Oh, it glitters and coruscates all right, and so it should. It is usually displayed under high-powered lighting. Let me show you some slides of diamonds that are used in jewelry of this peculiar caliber. Here we have one which has a feather extending in an arc across the diamond. That feather is really a large fracture, And this particular diamond is in imminent danger of breaking into two halves. In the next diamond, we have a lot of carbon spots. Now, these carbon spots are really not spots of carbon. It's merely a misnomer that's used for them. They are tiny included crystals which reflect the light in such a manner that they appear to be black. This entire diamond is absolutely filthy. Before World War II, such stones were not considered to be gem quality. A shortage of diamonds began after 1939, and there was a tremendous rise in engagements and marriages after 1941. The crafty merchants of diamonds discovered they could fit these stones, and the public knew no better. What glee! The situation has grown worse, if anything. There is a stream of dubious jewelry emerging from the sweatshops of New York. Look at the way things have changed. Miserable little crystals previously used for industrial abrasive are now shipped to India. There, simple operations are performed as they move through a string of villages. The wheels are powered by child labor. The end result might appear in one of those dinner rings. You know them, encrusted with minute diamonds. Such and such a total weight, the label says. The same class of thing is happening with the other precious stones too. Ruby, sapphire, and emerald in particular. If I have given the impression that all jewelers in the city are triangular fins cutting swiftly through the water, then I apologize. We have some very fine, service-oriented, ethical jewelry companies. Obviously, they cannot be named. You will have to make your own decisions. All I can advise is caveat emptor, or caveat emptor, depending on when and where you learned your Latin. But in English, let the buyer beware. In conclusion, Britannia House wishes to thank Koop Diamond Cutters, who allowed us to film this presentation. We spoiled their production schedules, monopolized their employees, and were generally disruptive. They forgave us everything. All the participants hope you have enjoyed the program. Goodbye.